How do you interpret Linux kernel logs? If you have ever wondered how to make sense of Linux kernel logs, you are in the right spot. These logs are essential for understanding what is happening in your system. They provide a window into system events, hardware status, driver activity, and errors. Let's break down how to interpret these logs effectively. First, it is important to know about the kernel ring buffer. This is a fixed-size memory area that stores log messages generated by the kernel while the system is running. It includes boot messages and overwrites old messages when it gets full. You can view these messages using the command called dmesg, which shows them in chronological order. Additionally, system logging services save these messages to persistent log files for later analysis. Next, let's talk about log levels. Each kernel message has an assigned log level that indicates its severity. These levels range from 0, which is the highest priority, to 7, which is the lowest. For example, level 0 means there is an emergency, and the system may be crashing. Level 1 indicates immediate action is required, while level 2 points to critical hardware or software failures. Understanding these levels helps you prioritize which messages to address first. Now, where do you find these kernel logs? Typically, they are stored in files located under the directory named varlog. Common files include varlog-kernlog, which contains dedicated kernel messages, and varlog-syslog or varlog messages, which include general system logs. You can examine these files using text commands like tail or grep, or even specialized log viewers. To access and filter kernel logs, you can use various commands. The dmesg command displays the current contents of the kernel ring buffer, which is great for real-time events. Another useful command is Journalctl with the option K, which shows kernel messages from the system journal. You can also use grep and tail to filter logs by keywords like error or warning to pinpoint specific issues. For instance, searching for hardware errors can be done with grep, error varlog-kernlog. Practical use cases for interpreting these logs include diagnosing hardware failures or driver problems. By checking for error or critical messages, you can identify what might be going wrong. Monitoring kernel module loads and unloads can help you understand system changes. If your system crashes or freezes, reviewing emergency and alert level messages can provide clues. Lastly, auditing system startup processes is easier when you look at boot messages stored in the ring buffer or boot log files. In summary, interpreting Linux kernel logs involves understanding log message levels, knowing where to find the logs, and using command line tools to filter and analyze them. This knowledge is essential for anyone looking to troubleshoot kernel-related issues or monitor system health within Linux distributions.